All right, so now we are going to do our activity for section 9.1. So I'm going to put the link in the chat for our Desmos activity today. That should be popping through here in just a second. Should be there. And I've got you guys restricted to just our first screen, which is a review screen. So I'm going to share my screen so you guys can see what that looks like. There we go. And please click the link, join the activity. And we'll get started here in just a couple moments. All right, guys, we're going to get started here. So we have some review screens here first, kind of like I like to do with our activities if I can. So first, there's a few things, basically like some 4 basic main topics in section 9.1. It is, hypotheses, interpreting p-values, the significance level, and errors. So we're going to have a couple screens here to go through those main ideas. First, stating an appropriate hypothesis. In any significance test, the null hypothesis has the form h sub 0 colon parameter equals value. The null hypothesis is the only hypothesis equal to a specific value. The alternative hypothesis has one of the forms where the parameter is less than a value, parameter is greater than a value, or the parameter is just not equal to that value, same value that we used above in the null hypothesis. You need to read the context carefully to determine the correct form of the alternative hypothesis, H sub A. Hypotheses always refer to a population. Be sure to state H sub 0 and H sub A, null hypothesis and alternative hypothesis, in terms of population parameters, not ever statistics. You can use P, right? Mu, sigma, if we're doing something with sigma. We will not be using P hat, X bar, anything like that. Those are statistics. We're using parameters. And we're now moving to the next screen. Interpreting p-values. The probability that measures the strength of the evidence against a null hypothesis is called a p-value. The probability computed assuming the null hypothesis is true, that the statistic would take a value as extreme as or more extreme than the one actually observed is called the p-value of the test. In other words, the probability of p hat occurring assuming that p is the true proportion is the p-value. Small p-values are evidence against the null hypothesis. Large p-values fail to give convincing evidence against the null hypothesis. Right. So this is, at this point in time, until we get into the next sections, we're using the p-value to hopefully help make a conclusion about our hypotheses. We then use significance levels to help us make those conclusions. When trying to determine significance, we can compare the p-value with a fixed value that we regard as decisive, called the significance level, written as alpha. When we use a fixed significance level to draw a conclusion in a significance test, we can use the following logic. If our p-value is less than alpha, then we reject the null hypothesis and we have convincing evidence for the alternative. If the p-value is greater than or equal to alpha, then we fail to reject the null hypothesis and we do not have convincing evidence for the alternative. Right. So I've kind of color-coded it for what we have evidence for and what we have evidence against. If we're looking at this little logic process. Right. Lastly, once we've made a conclusion, there is a possibility that we made an error. If we reject the null hypothesis when the null hypothesis is true, we've committed a type 1 error. If we fail to reject the null hypothesis when the alternative hypothesis is true, we have committed a type 2 error. And again, we have the table down here that we saw yesterday, All right, that is the truth about the population compared to the conclusion based on the sample, and it helps us determine if we have an error or if we have a correct conclusion. Okay, so in a nutshell, these are kind of the little nuggets that we need to take away from section 9.1 as we move into testing significance in 9.2 and 9.3. So these screens will remain open as we move through the problems. You may need or want to look back at them for reference, so they'll be available. So any questions or anything I can clarify before we move on to our activity and problems? And here we go. All right, so if you can all please make sure you move to screen 6, page 6. Right, that's where we're going here. This has our first 2 questions. For each of the following settings, describe the parameter of interest and state appropriate hypotheses for a significance test. All right, so I'm going to leave it to you guys to read these contexts here. Please read them carefully. And I do want to show you guys on the keyboard and in your text entry window here how you can get the notation that you may want. There are 2 options down here that you can click on if you really want to. And you're feeling savvy this morning, you can write this down by hand, take a picture of it, put that picture in the cloud, and upload your image here to show your answer. Otherwise, you can type it in here. If you click the type math thing, you'll get this little window that you can type in, and it makes it so that things type up nicely, right? So I can get that H sub 0, right? To get that, you just type an H and then you press Shift _, which is the button just to the right of the 0 on your keyboard, right? It's the dashes, right? That's underscore, it'll shift you down to that subscript spot. Type in your 0, click to the right using your arrow pad, your direction pad, right? And that will move you out of the subscript, right? You put your colon, P equals whatever value you have, right? Same thing can be done to get your H sub A. If you want the mu, right? Mu doesn't like to cooperate in that math type here as it's supposed to. So the trick is put \mu, highlight it, now click the type math and it will convert it to our nice fancy mu. Right, so if you need that notation, it is there. Also, if you need the not equal to sign, that is \neq, highlight, type math. And you get not equal to. You can also find different notations in the keypad that pops up when you click the type math. It doesn't have everything you might need, but it has a good selection. Right. So there's some little tips and tricks on how to type math if you need it. Otherwise, get it as close as you can. I'm sure I'll be able to figure out what you're trying to show me, and that's totally fine as well. Right, so we have these 2 contexts here. Please read them carefully. Make sure you tell me what the null hypothesis, the alternative hypothesis, and define the parameter, P or mu. Tell me what it is in context. Let's look at, if you look at the shared screen here, what the solution to the first question is. Right, and if you got your notation to look like this or not, don't stress too much on that. Some of the things are important, like you do need to use a colon in between your H sub 0 and then what P is. Don't use a dash, don't use an equal sign, don't do things like that. That's incorrect formatting. It means things that you're not intending. So we have H sub 0, colon P equals 0.85. That's our null hypothesis. The alternative hypothesis is that P is not 0.85. And this is because Janie just wants to know if the results are the same for her high school. She doesn't care if they're more than that or less than that. She just wants to know if it's the same as what this website reported. Right? Where P is the true proportion of students at the large high school who sleep less than 8 hours per night. And again, we're dealing with a parameter, which is a population. The population of interest is the students at the large high school. It is not the sample of 100. That would be a statistic at that point. Okay, so this is what we needed for the first answer, or the first problem. Right? The second one should follow a very similar kind of thought process. You'll have a null hypothesis, alternative, and our parameter in this case for question number 2 will be a mean or an average, which will be mu. Okay, and then set that up. I'll give you guys a few more minutes to come up with your solution for number 2, and then we'll review what that is and we'll move on. Let's talk about this. And I did have a question in the chat here that I'm going to kind of demonstrate again here. Typing math is difficult. It takes practice. There's an entire programming language that's about being able to type math and scientific notation and you know, sciencey things, mathematic things. It's called LaTeX. It's what I use to type up our study guides and things. It's its own language. It's like HTML. So struggling with it is okay. It's not necessarily intuitive. So one of the easier ways to make this do what you want is to type it without anything first. Just type the whole thing in. Something like this, right? Saying h sub 0 colon backslash mu equals 10. If I highlight this whole thing and click the type math, it'll convert the whole thing to that math type. Okay, that might be easier than trying to do each thing, or it's typically going to work out nicer than trying to type directly into the type math box. Why it cooperates that way and not in just like typing, I don't know, but that's one way to do it. All right. Again, don't get hung up too much on it. Get as close as you can, and that's totally fine. But again, let's look at what the solution for the second problem should look like. And that is right here on the shared screen. We have the null hypothesis should be that mu, or the mean, is equal to 10 minutes. And the alternative is that mu was greater than 10 minutes, all right? Because the suspicion is that the actual time it takes is more than what they're saying and then the claim, which is 10. So that is the alternative, right? Where mu is the true mean amount of time it takes to complete the census form, right? If you said that mu is the amount of time it takes, that is incorrect, right? Because mu does not represent a fixed, like one value from one sample. The amount of time it takes to complete varies, right? We could use a random variable to represent the amount of time it takes and then perform calculations about this random variable to try to get a mean mu, but that's not what we're doing. So we have to say that mu is the true mean amount of time, not that it is the amount of time. And I know it seems like a silly differentiation to make, but that's what it is. All right. So any clarification I can give you guys on these first two questions about writing a hypothesis? Alrighty. We're gonna move on to the next question. All right, this is from a context that we saw yesterday on our lesson. All right, we have Simon. checking about his large community college and the proportion of lefties that reside there. He chooses an SRS of 100 students and records whether each student is right or left-handed, and his hypotheses are stated below. We have the null hypothesis that P equals 0.12, right, or 12% is the decimal, and the alternative is that it just is not 0.12, where P is the true proportion of lefties at Simon's large community college. In Simon's SRS, 16 of the students were left-handed. A significance test yields a p-value of 0.2184. What conclusion would you make if alpha equals 0.1? Justify your answer. You may find it helpful to look back at screen 4 about how to interpret a significance level given a p-value. That might be useful. You also have, down here at the bottom, there should be a button that says Student Supports. There's some hints down there as well. Alrighty, so let's talk about this one. So many of you guys realize that our p-value is greater than alpha. Right, 0.2 is greater than 0.1. So we have a p-value that is greater than alpha, so we fall to this second tier of our logic thing here. We failed to reject the null hypothesis. We do not have convincing evidence for the alternative. Right? So that means in context, essentially, right, that the result could have happened if the actual proportion, assuming that the actual proportion is 12%. It's not unreasonable. So we do not have enough evidence to say that the proportion of left-handed students at the large community college is different than the national proportion, the assumed proportion of 12%. Right? It would be incorrect to say that the assumption of 12% is correct. Right? We just don't have evidence to say that it's incorrect. Right? You want to avoid making firm conclusions as far as like, this is the correct value, the other one was incorrect. We're just providing evidence for or against something. Right? And so this is what we could have written. Pop this in my shared screen here. So if you're looking at the shared screen, the possible solution could be because the p-value of 0.2184 is greater than alpha equaling 0.1, we failed to reject the null hypothesis. We do not have convincing evidence that the proportion of left-handed students at Simon's College is different from the national proportion. Okay. And so what we're doing is we're not just saying we failed to reject the null hypothesis, we do not have evidence for the alternative. We're providing the context again in our solution. That's incredibly important. Right? Is there anything I can clarify? Any questions you have?
So every time for p-value when it's so right now it is greater because it's 0.2 and alpha 0.1, so it will be greater. Okay, thank you.
Yeah, you're welcome. Yeah, we're literally comparing the values and being like, well, if this is, you know, based on our significance levels, right? When that p-value is less than alpha, like numerically less, we get that string of logic. If it is numerically greater than or equal to, we get the other string of logic. Yeah. Right. Let's move on to the next question. All right, and this one is interpreting a p-value. All right, when asked to explain the p-value in the previous exercise, lefties, a student says there is about a 22% chance that the null hypothesis is true. Explain why the student's explanation is wrong. Why is that explanation incorrect? Why is that not an appropriate interpretation of the p-value? Right? And again, there are some student supports down here at the bottom you may want to read through. Might give you some help. Right, and we want to explain why this is incorrect. All right, guys, we're going to talk about this one. This one is challenging, right, to kind of put to words why this is incorrect and really to interpret our p-value at this point where we don't actually know how it's been calculated. So we're going to look at this. So in the shared screen here, I have the short and sweet explanation. All right, either the null hypothesis is true or it's false. It isn't true some of the time and not true other times. All right, it either is or isn't. So we can't assign a probability to something that either is or is not true. Right? It's not true sometimes and false other times. It either is or isn't. Alternatively, that 22% represents the probability of getting that same result or something more extreme than that, purely by chance, assuming that the true proportion is 12%. All right. So the correct interpretation would be assuming that the true proportion of lefties is actually 12%. Then there's about a 22% chance that we get 16 out of 100 students who are left-handed or more purely by chance. Okay. Is there any questions or anything I can explain in more detail? So essentially the p-value is the probability of the observed outcome. It is not a probability of our hypotheses. All right. So next, we're actually going to skip the next problem and go to the 10th and 11th problem. So the 10th and 11th screens, those are multiple choice questions that we will end with today. Okay, so you can go ahead and skip over screen 9 and go right to screen 10, the mice in a maze multiple choice question. All right. We have this mice in a maze question, and then on the next screen we have the sales tax increase questions. All right, there are 3 multiple choice questions based on this one context, so I grouped them all together. Mice in a maze only had 1 question to go with it. All right, so in the mice in a maze question, you need to select the appropriate hypotheses for the significance test based on this context. Again, you should read the context carefully and then make your selection. The sales tax increase, right, is asking you to determine what a type 1 error in the context of the study would be, right? And then what's the correct interpretation of the p-value? So similar to the exercise we just saw. And based on the p-value, which of the following would be the most appropriate conclusion? So we have 4 multiple choice questions to work through. All right, and we're going to give you guys 8 minutes to work through these questions, and then we will review them, and then we'll be done for the day. Alrighty, here we go. We're going to go over these last few questions. So if you can, please go back to the mice in a maze screen. And we will discuss that solution, and then we'll look at the sales tax solutions. All right, so in this context here, we have a researcher. They are, putting mice in a maze. The mean time is 18 seconds for one particular maze. A researcher thinks that a loud noise will cause the mice to complete the maze faster, right? If we're completing something faster, then our time decreases. Right? She measures how long each of 10 mice takes with noise as a stimulus. The appropriate set hypothesis for the significance tests are choice number 4, the null hypothesis being mu equals 18. All right, the null hypothesis is always equal to a value, not less than, greater than, or not equal to. And the alternative would be that mu is less than 18. The thing we're trying to find evidence for is that the time will decrease. Right, so that is our solution. Is there anything I can clarify about this one? All right. Moving on to the sales tax increase questions. All right, in this context, type 1 error, right, occurs if the city council, right, I believe it is the second option, finds convincing evidence that a majority of residents supports the tax increase, when in reality at most 50% of the city residents support the increase. Right, type 1 error, right? If we go back to our screen number 5, the type 1 error is if we reject the null hypothesis when the null hypothesis is true. Right, so that means in this context, we would have found evidence for the alternative when the evidence shouldn't have supported it. Right, so we found convincing evidence that we had the majority when in fact we do not. Right, and then the correct interpretation of our p-value. The first 2 options are not correct. Right, remember the p-value is not a % chance of like one of our hypotheses, essentially, right? The third option will be correct, assuming that 50% of residents support the tax increase, which is our null hypothesis. There is an 18% probability that the sample proportion would be 0.527, which is the results of our sample, or higher by chance alone. That is the correct interpretation of our p-value. Lastly, based on the p-value of 0.18, which of the following would be the most appropriate conclusion? And in this case, the last option here is correct because the p-value is large. We're just saying that it's large because it is, for all intents and purposes, not terribly tiny. Right? We failed to reject the null hypothesis. We do not have convincing evidence that more than 50% of the city residents support the tax increase. All right. Are there any questions about the last few multiple choice questions here? Alrighty. So then, lastly, the practice problems and solutions for section 9.1 are available in Canvas under the chapter 9 resources in the chapter 9 module. So I do recommend doing those. It'll give you a little bit more practice on hypotheses and interpreting p-values and saying things like that that are a little bit kind of odd at the moment, and we'll get more practice with those. If you have any questions, comments, and concerns about anything that we've covered today, please make sure you let me know. Send me a message, send me an email, something to let me know. I will not see you guys again until, gosh, what would that be, like the 23rd? Right, it will be March 24th. Right, that will be the next time I see you guys physically or virtually through Teams. So please use that asynchronous time to get caught up on things, right? Because if you can get caught up using that time, then you get to not have to do it during spring break, which would be nice, right? So have a great rest of your day, a lovely weekend, an excellent week next week, and I will see you guys the following week on the 24th. And if anything comes up between now and then, let me know.